All right, folks. So hopefully by now you are pros at counting sig figs and rounding sig figs, because that's going to come in real handy when we start to actually do math with them. So this is what you would expect to do like in any given situation, right? Whether you're in lab or doing a problem in class, things like that. So we're going to start with multiplication and division. We're on page 4 in your note packet, and I want you to put a star by a chain is only as strong as its weakest link. Basically, if I'm thinking about this, if I'm multiplying or dividing something, your answer should have the same number of sig figs as the number with the least amount of sig figs. What that means is that if I have a number with 3 sig figs and I'm multiplying or dividing it by a number with 9 sig figs, my answer should only have 3 sig figs, right? If I only know this number out to 3 sig figs and this one has 9, my answer is only as good as the number of the least number of sig figs that I have. So, looking at this, if I do 2.31 times 2.21, I get a number on my calculator. By the way, sig figs are the bane of math teachers everywhere, okay? It's the bane of their existence, because at some point you might forget what class you're in and you might try to get a math number into sig figs. We're doing sig figs because we rely on measurements, whereas mathematics is absolute. So math doesn't use sig figs, but chemistry does, because we're in the art of measuring things. So anyway, if I have 2.31, I know that this has 3 sig figs, and 2.21 also has 3 sig figs. This number currently, this 5.083, currently has 4 sig figs. But I can round and get this number to 3, right? So you guys also learned how to round sig figs. So I have 5, 0, and 8. I know that the 3 is going to round me down. So to have an answer with 3 sig figs, I would round that down to 5.08. So if I'm looking at this, whoa, some of my numbers did not come over neatly. That's lovely. Okay. So that came out okay, and then all right. So when I look at this, my first problem, 2 times 4.5. Mathematically, I would get 9. So I need to look at my sig figs here, right? If I have 2 here, that's 1 sig fig. 4.5 has 2. My answer should only have 1 sig fig, right? I'm the least of the 2. This one still stays the same, right? 9 only has 1 sig fig. For 3.11 times 3.120, I need to look at these sig figs. 3.11 has 3 sig figs. 3.120 has 4 sig figs. My answer should only have 3 sig figs. So if I count across, I have 1, 2, 3 sig figs. That 3 is going to round me down. I'm going to get 9.70. If I'm dividing, which observes the same rules as multiplying, 9.5 has 2 sig figs. 3.942 has 4. My answer should have 2. So when I look at my answer, 2.4, that 0 rounds down, my answer is going to be 2.4. Here's where I think my slide went a little awry. I have 0.001030. Remember that those leading zeros do not count. So this number here has 4 sig figs, right? That 1 0 for a sandwich, 3, and then that trailing 0 after a sig fig. Those count, so 4. 4.23 has 3 sig figs. My answer should only have 3 sig figs. So on your paper, you can see that it's 0.0002435. Remember that these zeros do not count. So I have 243. That 5 is going to round me up. I still need to put the zeros, even though they're not significant. So I end up getting 0.000244. For 9.054 and 3.402, when I multiply those, both of those, and I'm going to switch colors here, both of those have 4 sig figs. My answer should also have 4 sig figs. My answer that is on your paper is this. So if I'm counting out 4 sig figs, then that's a 3. 1, 2, 3, 4. That's going to round down to 30.80. Remember that 0 is going to be significant at the end. Finally, 0.000420 has 3 sig figs. 20,000 only has 1. Remember, there's no decimal forcing those zeros to be significant. Therefore, my answer should only have 1. My mathematical answer is 8.4. So here's my sig fig. 4 is going to round down. I'm left with 8. Okay? So some people's minds are blown. They're like, how can I round that to 8? Like, that's not a very accurate answer. Remember that this is not a very precise number, right? If I only know something to the 20,000s, my answer can't be better than the number that I'm starting with. So if I'm looking at addition and subtraction, these are different rules. You might want to write yourself a note here. They're different operations, and we'll talk about why. For addition and subtraction, your answer cannot have more decimal places than the number with the least amount of decimal places. So addition and subtraction care about decimal places, whereas multiplication and division cared about sig figs. So if I have 4.507 minus 2.5, mathematically I get 2.007. But this has 3 decimal places. This has 1 decimal place. Therefore, my answer should only have 1 decimal place as well. So this rounds to 2.0. For 2.75 plus 3, addition and subtraction observe the same rules. There's 2 decimal places here. There are 0 decimal places here. Okay. So if I have 5.75 and I can't have any decimals in my answer, that 7 is going to round me up, and I'm left with 6. Okay. Oh, good, my slides came across. All right. So for here, I have 2 decimals. I have 4 decimal places. My answer should only have 2. So if I'm looking at this, there's my 2, right? That 9's going to round me up. I still have to put the 0 so that I have 2 decimals in my answer. Okay, again, we're not playing with sig figs here necessarily. We're caring more about decimal places. Here I have 2 decimal places. Here I only have 1. So here's my mathematical answer. I should only have 1 decimal place in my answer. That 5 is going to round me up 24.5. For 4.25, I have 2 decimals. That's a 2. That's a bad 2. There we go. This has 4 decimals too. So 2 decimals in my answer. That 2 rounds me down. 4.35. 1 decimal here, 3 decimals here, 1 decimal in my answer. That 9 rounds me up, so 13.4. This one has 3 decimals. This one has 3 decimals. So I need 3 decimals in my answer. So sometimes these numbers will still stay the same, right? My mathematical answer will be my sig fig answer. This has a whole lot. This has 6 decimal places. This one only has 2. So I should only have 2 in my answer. That's going to round down to 20.03. This one has 2 decimal places. This one has 4. With 2 decimals in my answer, that 8's going to round me up to 4.15. Finally, last but not least, if I have 23.4, that has 1 decimal, 9.010 has 3 decimals. So I need 1 decimal in my answer. This one's going to be 14.4. So remember, multiplication and division, I care about the least number of sig figs in the problem. Addition and subtraction, I care about number of decimal places. All right.